All right, so we'll start with Aleksander here, who's going to be talking about teaching data science in adverse circumstances.
It's a little awkward, but well, this is plan B. Apologies. Adverse circumstances, and this was an example of. So I live in Argentina. That is the another part of the adverse circumstance. It's a nice country at the very south of South America. Middle-income country. We have a rather high poverty rate, and we have inflation at 113%. So think about that the next time you complain about 6 that you have here, where it could be considerably worse, and everything is relative, as we all know. I live in the capital city, Buenos Aires, and I'm going to pull this down a little. It's home to about a third of the population, rather concentrated. And I work at a public university there called UNSAM, Universidad de San Martín, which public university in Argentina means that the students don't pay any fees. So it's completely subsidized by, financed by the government or the state. So during COVID, we actually surveyed the students here, and we found that more than half of them do not have access to laptops or computers at home. This became relevant because everything was online. Most of them actually work while they're studying. I also work at Escuela de Humanidades, which is essentially a liberal arts college. I work in a communication program, so my students often want to be journalists or PR people. It's not really the math and computer science crowd. So that poses some challenges, lack of resources, financial resources, most importantly. There are some language barriers, arithmophobia and technophobia to a lesser degree as well. And why care about this? We shouldn't exclude people based on language or financial resource situation. And I also think it benefits society in general if journalists are actually statistically literate. That's for the better good. We can discuss whether it matters for PR people. We have a host of English majors who are fresh out of work because of ChatGPT. If we give them some data science, they have some marketable skills. We can help them out. But mostly and foremost, this diversity enriches our community. They bring in perspectives and they bring in new inspiration, and that's good for us. So the resource situation was very easily solved when posit.cloud became available. There's a free version, which I use with my students, and it runs on everything. What you see here is an 18-year-old, 1 laptop per child computer. They were distributed by the government almost 2 decades ago. Now the only use they have is to browse the internet, and that is essentially all you need for posit.cloud. And I have another example here. This is me checking in on a training job while I'm out to dinner on my cell phone. Not recommended, but it does actually work if it's absolutely needed. And then I want to talk a little bit about language barriers in R itself. Take a look at this code. This is what our code might look like if you see it for the first time and your first language is not English. This is essentially a trivial data analysis from the documentation of dplyr. But think about that for a moment. If you don't have semantic access to the function names, then it's going to be a little more difficult. This is not something that I think we can solve by forking R and rewriting all the functions, but it bears thinking about it, we should keep it in mind that there is going to be a steeper learning curve for this population, for any programming language, in fact, because they're all going to be English-based. There's interface issues. That's easier to solve, and in fact, it has been solved for French. Not for my use case, but I'm sure that's going to be updated shortly. Easy enough to fix, and it does help. But the most important, I think, the most important one is to have teaching materials in the language of the students. And here I am trying to make a contribution by publishing everything that I use and create. It's freely available online. And there are more people in the community who do this. So there is a growing, not enough, but there is a growing body of teaching materials that we can work on. So arithmophobia, the fear of numbers. I have sort of 3 areas where I've been trying to work on that. The first is curriculum. This is sort of a standard setup for intro to stats. And this is how I reshuffled it for my purposes. I'm not saying this is the only way to do it, but I move certain things around. Hopefully that makes it easier for the student to get into this. And I'm going to go through the top 2 here. The first one is hypothesis testing with Karl Popper. And I bring him up to week 3 for 2 reasons. First of all, I can tell my students these are humanities students, and Karl Popper is a philosopher. He's one of your lot, yet he is fundamental to everything we do in empirical science. And the other reason is there's no coding homework in week 3. And that reduces the likelihood that the students drop the class. They've just been exposed to what you saw, and they need a little break. So that's the other reason. And then I moved the chi-square analysis up. It requires very little data to get going. Show up with 4 numbers, and you're essentially done. Visualization is easy, not beautiful, but it is easy to get going, and it's a very intuitive imbalance that we're analyzing, and it doesn't have a lot of requirements. If any of you have done a t-test lately, you will remember that there are up to 7 assumptions attached to that. Here there are very, very few. And arithmophobia, there's only 4 numbers you have to deal with here. You get a result. So the other thing I like to do is use relevant data. What you see here is data that gets published by the government on income, among other things. And with very little analysis, you get here there's a gender gap in pay. The mean salary is actually quite low, ridiculously low, and there's a huge standard deviation. So you have a lot of income disparity. With very little analysis, you describe Argentine society, and I think this is interesting, more interesting than penguins and empty cars for this population, because it speaks to issues that matter to us in the society where we live and work and study. So I think this is interesting. If anyone is interested in live coding and Schadenfreude as a pedagogical device, I do live code a lot to demystify the process. It's a lot of trial and error, and it's very iterative, and it takes forever. That's something that should be known. And Schadenfreude, the way I use that as a pedagogical tool is to take some bad research, some bad data analysis, and ask my students to have at it. And they do that with gusto. And it works. For me, it's worked very well, because it's sort of, you can learn from the errors of others before you learn and have the confidence to learn from your own errors. So from that point of view, It's useful, and I want to take a moment to think about what it is that we teach. When we teach data science, you've seen this surely before. This Venn diagram was omnipresent in data science presentations at the beginning when we sort of had to justify ourselves. And I feel we've sort of used it up. But anyways, so as a teacher, I think we're doing this. I think we're doing this to these two parts. And I really think that it is the student who is the domain expert. So we create a data science team here, providing the different components on either side. And I want to show two examples. The first one is Matthias Salto. He studies billboards in the subway system in the capital city. And is interested in warm and cold colors and how they relate to the product that's being advertised. When you pry open an image, you get a bunch of color codes. And then he took those and created color profiles for the different images for the different products that he was studying. Here, you have headache drugs, there's candy in the middle, and cell phone service on the right there. And then he created a classifier model using the colors as predictors, essentially, which I thought was very clever. And I don't know anything about color, as you can tell from my slide deck. So in this case, it really is the student who brought that expertise to the fore, and we were able to do this. I can help with code, and I can help with methods. And then there's Camila Ramirez. She works on animated shorts, small films that have no dialogue. So it's all visual language. And she's interested in studying color as a semiotic resource. And when you pry open a movie, you download it from YouTube, you get a series of frames. You get 29.3 frames per second or something like that. And then you can do the same thing. You can do a color analysis on each frame, and now you have a color timeline for the movie. And when I saw this, I said, I don't know what's going on in this movie, but I know when it's going on, because there's a timeline along the x-axis. And so this is, quantitative semiotics. I thought it was absolutely brilliant. Again, the student is the expert here. I've provided some method and some code, but this is really the work of a domain expert that in collaboration. So I think I don't think we should be using this diagram anymore, and I think I'm going to skip to my conclusions now. If you teach data science, you should try to be relevant and be real and be there. And if you don't teach data science, you should keep supporting those of us who do. Thank you.
Thanks, Aleksander.
Should I leave this? Or? Oh, yeah. Hang on.
Yeah, Jill will be next, and she'll be virtual. So we do have a minute or two for questions if anyone does have one. You could just raise your hand at this point if you don't have Slido up. I have one. I was thinking, like the code is in English, like you were saying, and it's hard to get that like translated and still work, right? Is there anything that you do to try to get over that barrier? Like, what are the tools that people use to help people understand if English isn't their first language?
Well, so there's two. Well, first of all, the function names are arbitrary, but they haven't been assigned randomly. I mean, they have been assigned by a programmer for to be able to retrieve the information that's encoded in the function. I mean, there's a reason we name functions. And as I said, and I sort of want to stick to that, I don't think we should try and overcome this, because then you would sort of disconnect a linguistic minority from the general community, and that's division. That's not diversity, and it would be counterproductive in a long in ways that are too many to sort of list. So it is more about if you write your own function, write it in any language you want. If you use somebody else's functions, you're going to have to learn enough English to be able to read it. So it's just, beware that there's a steeper learning curve. I think that's that's my answer to that problem, and be sensitive to it.
Cool. Any other questions real quick? Yeah, she's got one. Yep.
Hi, thank you for the talk. My question is, what can we as contributors to our universe do in terms of like our write-up and our documentation that we post that can make things easier for folks that don't maybe operate in English as their primary or preferred language?
So the question was for the virtual audience, what can we in our universe do to kind of help make it easier for people who don't speak English as a first language and whatnot?
Yeah, I think publishing teaching materials online, and I guess we need to do a better job marketing them so that other people get a hold of them and can use them. I would love to have a curated collection of textbooks. In my case, textbook in Spanish for statistics. I haven't found that. I found bits and pieces that are useful. But I think that's it. You have to put your stuff online and make sure you have to make sure it's licensed correctly with a free-for-all license, share alike. Creative Commons, I think, is the most useful license, so that other people can use it. And contact people and collaborate. I think that's, I think we're also doing that, but we could do more of it.
Great. Thank you so much, Aleksander.
Absolutely. Thank you.